In this video, I'm going to review properties of exponents, and I'm going to start with a division problem. As you can see, I've done the problem twice, and I have slightly different answers, and we're going to discuss the reason for that. First of all, in this first example, I have actually expanded the factors of the problem. We have x squared divided by x to the fifth, and I just simply wrote out all the factors and then canceled equal factors in the numerator and denominator. As a result, I wind up with 1 over x cubed. Did the same exact question, this time applied the properties of exponents, where you subtract those powers, and when you do, you get x to the negative third. Now, as a result, we have two slightly different answers, but they are equal answers because we just did the same problem. These are called equivalent forms. This is the math symbol for therefore, and now I would like to just explain why these answers are equivalent and how you can transform from one to the other very quickly. First of all, in the first example, you have 1 over x cubed, and in the second, we have x to the negative third. You can see that they're very similar to each other, except for one has a negative 3 in the numerator, and the other one has a positive 3 in the denominator. So as a result, you can quickly transfer from one to the other just by changing the position in the fraction. If I had 1 over x to the negative second power and I wanted to make that a positive, again, to obtain its equivalent form, you just change its position in the fraction so that x squared comes to the numerator and it switches with the 1, and of course we know we don't have to write that 1. With that being the case, let's take a look at a few of these examples. In this example, I have 2x cubed y to the negative second power. So if I want to write this without those negative exponents, then I'm just going to change the position of the exponent in the fraction. So I'm going to make that happy, so to speak, and bring it to the downstairs of the fraction. And that is simply how you rewrite those. Let's look at a few more examples. All right, on this one we have a negative 4 u to the negative third times v cubed. Now, what I need to point out is that every constant, every numerical value does have an exponent, and it is the 1. And as you can see, there's the 1. It doesn't have to be there, but it is implied, so just keep that in mind. That 1 is positive, so it's going to remain in the numerator. The v cubed is also positive, and the only thing that we're going to change here is that u to the negative third, we're going to make it positive by changing its position in the fraction, and it's going to be negative 4v cubed over u cubed. I also want to point out that this is a floater. We can have it in the numerator, denominator out to the side. It really doesn't matter because it's going to be negative one way or the other. Okay, let's take a look at number 3. Again, this is very simple, very similar to number 1. You're going to get 2x over y squared. And number 4, I'm going to put this, draw a division bar and make this a fraction so you can see this a little bit. All I need to do is do a little bit of a flip here with this fraction. This is negative, obviously, and remember, in order to make them positive, you bring them to the downstairs of the fraction. So all that I'm going to have left in the numerator is a 1, and that's going to be v to the first, and we don't really have to write that 1. Next, this is no negatives on this one, but it is a raising a power to a power review. Again, I want to point out that that numerical value 5 does have a 1 as an exponent. And I'm just pointing that out because when we take a power to a power, we have to distribute to all of the factors inside of the parentheses. So that will actually be a 5 cubed times m to the 9th power. And I'd say that this is probably the number one mistake when doing these types of questions, is that we tend to forget about the 5 needing to be cubed. So our final answer is going to be 125 m to the 9th power. And number 6, again, we're going to square that negative 5 because it does have an exponent of 1. And that's going to give us a positive 25 b to the 6th power. And this is a review of the property or the exponent of 0. Anything to the 0 power is equal to 1. So since this whole thing is set up to the 0 power, the whole thing is equal to 1. I'd like to take a minute just to explain that. If you had x to the second power, x squared divided by x squared, if we were to use the power rule, we would subtract those and we would get x to the 0 power. But the other thing is, anytime you divide a number by itself, you get the number 1. So again, similar to the question number 1, deductive reasoning here is we have two slightly different answers, but we just did the same exact question and got an answer. So that means that these are equivalent answers. So x to the 0 power is equal to 1. Or, in other words, anything to the 0 power is going to be equal to 1. We want to be real careful about this negative here because it is actually a negative 1. And I'm going to write that negative 1 times n to the 5th power, quantity cubed. And I'm going to make sure that I cube that negative 1. And I know when you have an odd number of negatives, you're going to wind up with a negative. So this is going to be negative n to the 15th power. Number 9, we have this negative out here. I also want to make you aware of the fact that this is a floater. It can go numerator, denominator, out to the side. It's not going to change the fact that this is a negative problem. So let's just go ahead and start with just simplifying that denominator and taking that power to that power, and we get b to the negative 6th. Now at this point what I could do is just simply subtract these exponents. 1 minus negative 6 is like 1 plus 6, which is b to the 5th. Or again, let me just review that concept of negative exponents. I'm going to bring the negative 6 to the upstairs, make it positive, bring the b to the negative 1st to the downstairs, make it positive, and then use the power rule where I subtract. You notice I got the same exact answer as I did before. All right. This one's slightly more advanced. We have to remember again that there's a negative 1 here and a negative 1 here. And you could do this a multitude of ways, but keep in mind that that's a negative 1 to the negative 4th power. Let's start by maybe making this positive and this positive by switching those two values' position in the fraction. And there's a multitude of ways you can do this. I'm just starting with making that those outside exponents positive. And now as a result, what I can do is take that power to the power, and this is going to give me a negative v to the negative 4th. Just simply remove the parentheses. And whenever you take a negative 1 to an even power, your answer is going to be positive. So this actually changes to a positive v to the 16th power. Now, of course, we can apply the power rule. We can subtract these. Negative 4 minus 16 is negative 20, so that could be v to the negative 20th power. Of course, we want to make sure we use only positive exponents, and so we can make that negative 1 over v to the 20th power. Again, back here, what I could have done, back it up, rewind the tape, I could have also have brought this down to the downstairs of that fraction and make it positive and then adding those together and get the same exact answer. Again, the placement of this negative is neither here nor there. It can go in the upstairs, downstairs, or out to the side. The answer is still negative. Number 11, once again, anything to the 0 power is going to equal 1. And number 12, again, anything to the 0 power is going to equal 1. Power to a power is going to give us 10. And that concludes this video.